In the coming year, nearly $500 billion will be invested worldwide in the exploration, development, and distribution of petroleum products. And there is no slowdown in sight. There are, however, challenges to be met if the oil and gas industries are to keep pace with the world's appetite for energy. Among these challenges are the technological advances required to operate in increasingly remote and unfriendly offshore environments, and the demand upon construction resources. The frequent occurrence of catastrophic storms, coupled with the necessity for deep water drilling, call for new applications of engineering expertise. The stability and durability of massive new deep water drilling platforms, just one of which costs more than $1 billion, is of paramount importance to offshore operators and investors. Solutions are urgently being sought today for the needs of tomorrow. Since 1981, Versabar, an engineering company with headquarters in Houston, Texas, has been applying their innovative skills and inventory of resources in response to the challenges of offshore heavy lift operations. The evolution of Versabar project solutions has led to 44 international and domestic patents, the latest of which will revolutionize the speed, safety, and cost of developing and deployment of offshore platforms, the Versabuoy. In 1999, Versabar, in response to a challenge presented by Chevron, installed 3 5,000-ton topsides in Venezuela's Gulf of Maracaibo with a new heavy lift system called the Versatruss. The Versatruss system lifted the platforms from the underside versus the traditional method of using a derrick barge. The next generation heavy lift system, called the bottom feeder, was deployed in the Gulf of Mexico in June of 2007. The bottom feeder went from concept to completion in just 14 months, utilizing a new patented articulating joint which attaches the truss work to the barges. The patented bidirectional joint has the effect of dramatically dampening wave motion on the offshore structure. The pin-in-pin joint was applied with immediate success to the company's new lift system, creating a stable base for the 4,000-ton capacity deck salvage system. This system, in 2 years of operation, has demonstrated remarkable stability in adverse sea states as it goes about its work of salvaging hurricane-destroyed platforms in the Gulf of Mexico. In this model testing video, it is clearly demonstrated how the articulating joint decouples the wave action between the barges and the truss system, allowing safe lifting and compensating for any skewed loading of the lift system. Once again, this system validated the vision of John Cacciatarian, the president of Versabar, and his revolutionary design for offshore platforms, the Versabuoy. Traditional spar-designed platforms suffer great transfer of wave moment to the topside structure, but the Versabuoy decouples the wave motion from the topside, as shown in this early tank test video. Versabuoy has approximately 10% of the wave motion of a traditional spar. Preliminary design concepts for the use of the joint for topsides led to full-scale wave testing at the model basin facilities in Escondido, California. In this model testing video, the superiority of the joint over conventional methods of topside support is readily evident. As the topside surface area is increased and additional buoys added, even greater topside stability is achieved, as validated through additional model testing. Yet superior wave motion is not the only advantage of the Versabuoy. Traditional large hull and spar fabrication is only available in a handful of construction yards worldwide, and construction lead time is counted in years. The buoys for the Versabuoy system can be fabricated in any one of the hundreds of fabrication facilities around the world, resulting in reduced schedule and a considerable reduction in cost. Furthermore, installation of the Versabuoy does not require a large-capacity derrick barge or an extensive fleet of expensive assets, but rather a modest spread of work vessels, which facilitates installation in a fraction of the time. Versabuoy is the first new offshore platform technology in the past decade. Versabuoy's construction flexibility, its speed of deployment, operational capabilities, and scalability allow first oil at 50% of the cost of a traditional production platform. Versabuoy, the future of deepwater oil production.